The biggest galaxy we have ever discovered is so large that your brain will struggle to truly understand it. This is not an exaggeration. This is not dramatic storytelling. This is the honest truth about a cosmic monster that sits over 1 billion light-years away from us, quietly existing in the darkness of space, holding more stars than you could ever count in 1 million lifetimes. If you are anything like most people, you probably thought you understood how big things could get in space. You have seen the pictures of Jupiter dwarfing Earth. You have heard how our Sun could fit 1 million Earths inside of it. You might have even wrapped your head around the fact that our Milky Way galaxy stretches across 100,000 light-years from one side to the other. But all of that, every single comparison you have ever heard, becomes almost meaningless when you learn about what astronomers found hiding in a distant corner of the universe. Let me set the stage for you. Our home, the Milky Way, is what scientists call a barred spiral galaxy. It has beautiful, curving arms made of stars, gas, and dust, all swirling around a central bulge where an enormous black hole sits. Our galaxy measures roughly 100,000 light-years across. That means if you could somehow travel at the speed of light, which is the fastest anything can move in our universe, it would still take you 100,000 years to cross from one side of our galaxy to the other. That is already almost impossible to truly grasp. 100,000 years is longer than modern humans have existed. It is longer than the time since we first learned to paint on cave walls. Longer than every civilization that has ever risen and fallen on Earth combined. And yet that is just the width of our own little corner of the cosmos. The Milky Way is home to somewhere between 200 billion and 400 billion stars. Each of those stars might have planets orbiting around them, moons circling those planets, asteroids tumbling through space, and comets streaking through the void. Our Sun is just one of those hundreds of billions of stars, sitting about 26,000 light-years from the galactic center in a quiet neighborhood called the Orion Arm. When you look up at the night sky from a dark location, that hazy band of light stretching overhead is actually the combined glow of billions upon billions of distant stars in our own galaxy. For most of human history, we assumed that was everything. We thought our galaxy was the entire universe. It was not until the 1920s that an astronomer named Edwin Hubble proved that those fuzzy smudges people had been seeing through telescopes were actually entire galaxies themselves. Each one containing billions of their own stars, each one impossibly far away from us. That discovery changed everything we thought we knew about our place in the cosmos. Our galaxy was not the whole universe. It was just one galaxy among many. Today, we estimate that there are around 2 trillion galaxies in the observable universe. 2 trillion. Each of those galaxies contains billions or even trillions of stars. The numbers become so large that they stop having meaning to our human brains. But here is what makes this story interesting. Not all galaxies are created equal. Some are tiny dwarf galaxies with just a few billion stars. Others are massive spirals like our Milky Way or our nearest large neighbor, the Andromeda Galaxy. And then, sitting at the extreme end of the scale, there are the true monsters of the universe. Galaxies so enormous that they make our Milky Way look like nothing more than a speck of dust floating in an empty warehouse. The galaxy I want to tell you about today is one of those monsters. It goes by the somewhat boring name IC 1101, which comes from its entry number in a catalogue of celestial objects created over a century ago. But do not let the dull name fool you. There is nothing boring about this cosmic giant. IC 1101 sits at the center of a cluster of galaxies called Abell 2029, located in the direction of the constellation Virgo as seen from Earth. When astronomers point their telescopes toward this region of the sky, they see a massive collection of galaxies, all bound together by gravity, dancing around a common center. And right in the heart of that cluster, dominating everything around it like a cosmic emperor on a throne, sits IC 1101. This galaxy is estimated to be somewhere around 4 to 6 million light-years across. Let that sink in for a moment. Our Milky Way, which already seemed impossibly large, is only about 100,000 light-years wide. IC 1101 is roughly 40 to 60 times larger than our entire galaxy. IC 1101, where our Milky Way currently sits, it would not just engulf our galaxy, it would swallow our entire cosmic neighborhood. The Andromeda Galaxy, which is about 2.5 million light-years away from us, would find itself inside IC 1101 massive body. The Triangulum Galaxy, another neighbor of ours, would be consumed as well. All of the dozens of smaller dwarf galaxies that orbit around us would simply become tiny components of this giant's vast structure. But size is just the beginning of what makes IC 1101 so incredible. This galaxy is estimated to contain around 100 trillion stars. 100 trillion. Our Milky Way has maybe 400 billion stars at most. That means IC 1101 has roughly 250 times more stars than our home galaxy. If you started counting stars in IC 1101, 1 star per second without stopping, it would take you over 3 million years just to count to 100 trillion. And that is assuming you never slept, never ate, never took a break of any kind. But here is where the story becomes truly strange. Despite containing 100 trillion stars, IC 1101 is actually a dying galaxy. The stars within it are almost all old. Most of them are what astronomers call red giants or yellow stars, ancient stellar objects that have already burned through most of their fuel. Very few new stars are being born inside IC 1101. This might seem strange at first. With so many stars and so much mass, you might expect IC 1101 to be a hotbed of stellar activity. But remember how it grew so large. And this is where the mystery deepens. IC 1101 grew to its enormous size through normal processes alone. It became a giant through an act of cosmic violence that has been happening for billions of years. IC 1101 is what scientists call a cannibal galaxy. It has been eating other galaxies. To understand galactic cannibalism, you need to think about how gravity works on the largest scales. Galaxies do not exist in isolation. They are grouped together in clusters, held together by their mutual gravitational attraction. Within these clusters, galaxies move around each other, sometimes passing close by, sometimes colliding directly. When two galaxies get close to each other, their gravity begins to distort their shapes. Stars get pulled out of their normal orbits. Gas and dust get compressed and stretched. If the galaxies are similar in size, they might merge together over hundreds of millions of years, eventually forming a single larger galaxy. But if one galaxy is much bigger than the other, something different happens. The larger galaxy simply absorbs the smaller one, stripping away its stars and gas, adding all of that material to its own massive body. This is what has been happening to IC 1101 for billions of years. As the largest and most massive galaxy in its cluster, IC 1101 sits at the gravitational center of everything around it. Smaller galaxies that venture too close get trapped by its enormous gravity. They spiral inward, getting torn apart and consumed over millions of years. Each meal makes IC 1101 a little bit bigger, a little bit more massive, a little bit more dominant. Scientists estimate that IC 1101 has undergone at least 76 major mergers over its long history. 76 times another substantial galaxy fell into this cosmic giant and was absorbed into its body. And those are just the major mergers. Countless smaller dwarf galaxies have also been consumed. Galaxies so small that they barely registered as a meal for this enormous predator. The evidence for this cannibalistic history is written in IC 1101 very structure. When you look at a galaxy like our Milky Way, you see a beautiful spiral pattern. Those spiral arms are regions where stars are actively forming, where clouds of gas are collapsing under gravity to create new stellar nurseries. IC 1101 looks nothing like this. It is what astronomers call an elliptical galaxy, which means it has a smooth, oval-shaped appearance with no spiral arms at all. Elliptical galaxies form when spiral galaxies merge together. The violent gravitational gravitational interactions during a merger destroy the delicate spiral structure, mixing all the stars together into a more random, spherical distribution. The fact IC 1101 is an elliptical galaxy tells us that it has experienced so many mergers that any original spiral structure it might have had has been completely erased. All of those collisions, all of that gravitational chaos has stirred up the stars like someone mixing ingredients in a cosmic bowl. But there is something even more remarkable hiding at the center of this giant galaxy. Sitting at the very heart of IC 1101 lies one of the largest known supermassive black holes in the entire universe. Every large galaxy has a supermassive black hole at its core. Our own Milky Way has one called Sagittarius A star, which contains about 4 million times the mass of our Sun. The black hole at the center of the Andromeda Galaxy is even bigger, containing somewhere around 100 million to 200 million solar masses. But the black hole at the center of IC 1101 is in a completely different category. Scientists estimate that it contains somewhere between 40 billion and 100 billion times the mass of our Sun. To put that in perspective, this single black hole might have 25,000 times more mass than the black hole at the center of our entire Milky Way galaxy. Let me help you understand just how massive this is. If you could somehow weigh the Earth, you would find it has a mass of about 6 trillion kilograms. That sounds like a lot until you compare it to the Sun, which is about 330,000 times more massive than Earth. Now, multiply the Sun's mass by 50 billion. That is roughly how much mass is packed into the supermassive black hole at IC 1101 center. All of that mass is compressed into a region of space from which nothing can escape. The gravitational pull at the event horizon, the boundary of the black hole, is so intense that even light itself cannot break free. For a black hole of 50 billion solar masses, the event horizon would have a radius of roughly 150 billion kilometers. That is roughly 16 times larger than our entire solar system from the Sun to the orbit of Neptune. If you placed this black hole where our Sun is, its event horizon would extend well beyond the orbit of Pluto, engulfing everything we consider our cosmic home. What would it be like near this monstrous black hole? The physics of such extreme environments is bizarre and counterintuitive. Time itself would pass differently near the event horizon compared to far away. Space and time themselves become so warped that the concept of escaping becomes meaningless. But here is something remarkable. Despite its enormous size and terrifying properties, the black hole at IC 1101 center is currently relatively quiet. It is not actively devouring huge amounts of matter. There is no brilliant accretion disk swirling around it, no powerful jets shooting into space at nearly the speed of light. The black hole is there, waiting, but it has already consumed most of the material that was easily within reach. This quietness is actually related to the same phenomenon that has stopped IC 1101 from forming new stars. Most of the gas in the galaxy has already been used up, and without gas falling toward the center, the black hole has little to eat. The giant galaxy and its giant black hole have reached a kind of equilibrium, each one having shaped the other over billions of years of shared evolution. Now, I want you to truly appreciate the scale of what we are talking about. Imagine you could somehow travel from one end of IC 1101 to the other. You would need to cross somewhere between 4 and 6 million light years. Remember, light travels at about 6 trillion miles per year. Even at that incomprehensible speed, crossing IC 1101 would take millions of years. But let us try another comparison. The Voyager 1 spacecraft, launched by NASA in 1977, is the fastest human-made object ever to leave our solar system. It is traveling at about 38,000 miles per hour relative to the Sun. At that speed, Voyager 1 would take about 80,000 years just to reach the nearest star to our Sun, Proxima Centauri, which is only about 4 light years away. To cross the entire Milky Way at Voyager speed would take about 2 billion years, and to cross IC 1101, you would need somewhere between 80 billion and 120 billion years. That is more time than the universe has even existed. Even with our fastest spacecraft, crossing this single galaxy would be completely impossible. The light we see from IC 1101 today left that galaxy over 1 billion years ago. It has been traveling through the void of space for more than 1 billion years just to reach our telescopes. When that light began its journey toward us, life on Earth was still mostly single-celled organisms. Complex animals had not yet evolved. The dinosaurs would not appear for another several 100 million years. Every major event in human history, from the first civilizations to the invention of the telescope itself, happened while that ancient light was still crossing the emptiness between galaxies. We are not just looking at a distant object. We are looking back in time. We are seeing IC 1101 as it was over 1 billion years ago, not as it is today. And yet, from our tiny vantage point on a small rocky planet orbiting an ordinary star in an unremarkable part of an average spiral galaxy, we have somehow figured out that this monster exists. We have measured it, we have studied it, we have understood it. The biggest galaxy we have ever discovered is bigger than your imagination. But the fact that you can imagine it at all, that you can hold in your mind a picture of 100 trillion stars spread across millions of light years, that you can wonder about its past and future, that is perhaps the most amazing thing of all. If you found this journey through the cosmos eye-opening, consider subscribing to explore more mysteries of our universe. The cosmos is full of wonders waiting to be discovered.